Let's talk about something we all experience every single moment of our lives, but almost never think about. Why does time have a direction? Why does it only, and I mean only, ever seem to move forward?
Think about it. You can remember what you had for breakfast this morning, but you have absolutely no idea what you'll have tomorrow. The past is known, but the future, that's a total mystery.
And we all feel this one personally. Every day, we're a little bit older. It's just a constant one-way journey from young to old. There's no reverse gear.
And it's not just us. Look anywhere in the world. You can drop a glass and it'll shatter into a million pieces. But have you ever seen those pieces jump back together? Nope, never happens.
So, what is going on here? Why this unstoppable forward march of time? Well, if you've ever asked yourself that, you're tapping into one of the deepest questions in all of physics.
And here's where it gets really weird, because the fundamental laws that run the entire universe, they don't seem to care which way time flows. And that sets up a huge paradox.
Okay, so check this out. On one hand, you have the actual rule book of the cosmos, the equations from Newton to Einstein to quantum mechanics, and if you run the math backwards, it all still works perfectly. The laws themselves are totally fine with time going either way. But then on the other hand, you have, well, reality, our universe, where things only happen in one direction. So how on earth do you get a one-way street from a set of two-way rules?
And this isn't just some philosophical thought experiment. This is a core puzzle. It's like the laws of the road say you can drive in either direction, but for some reason we see every single car in the universe driving the same way.
Well, the best explanation we've got for all this one-way traffic comes down to a single, powerful idea: entropy. You can think of it as the engine that's actually pushing time forward.
So what even is entropy? Put simply, it's just a measure of messiness. A neat, tidy room has low entropy. A messy room has high entropy. An egg in its shell is low entropy. Scrambled eggs, that's high entropy. See? Simple.
And this leads us to one of the most bedrock laws in all of science, the Second Law of Thermodynamics. All it really says is that, left to its own devices, a system, like our universe, is always going to get messier. Disorder, aka entropy, always tends to increase.
And you see this principle playing out absolutely everywhere. An ice cube in coffee is an ordered system. The cold stuff is here, the hot stuff is there. As it melts, everything mixes up into a more disordered, lukewarm state. That's entropy going up. Metal rusting, stars burning their fuel, a drop of ink spreading in water. It's all the universe moving from a state of order to disorder.
So here's the big takeaway. The arrow of time isn't some property of time itself. It's a consequence of this process. The reason we feel time moving forward is because that's the direction where things get messier. The past is simply the state with less entropy, and the future is the state with more.
Okay, but wait a second. That just kicks the can down the road, right? If the universe is always getting more chaotic, then that must mean it started out incredibly orderly. So why? Why did it begin in such a neat and tidy state?
To get to the bottom of that, we have to travel all the way back to the beginning, to the Big Bang itself. And it turns out, this is one of the biggest unsolved mysteries we have.
Now you'd think that a blazing hot, super dense soup of particles would be the definition of chaos, right? But gravitationally speaking, it was the exact opposite. Everything was spread out so smoothly and uniformly. That was a state of incredibly low entropy. It was like the universe was a perfectly wound-up clock, just waiting to start ticking and unwinding.
The famous physicist Richard Feynman put it just perfectly. He said that for some reason, the universe started out this way, and it's been getting more disordered ever since. Figuring out that for some reason is what keeps a lot of physicists up at night.
So, why does entropy always increase? Is it like a force? Not really. It's actually just a game of pure, simple probability. The universe is just playing the odds. Let's break it down. If you could watch just one single particle bouncing around, its path is completely reversible. A video of it playing forwards or backwards would look exactly the same. But when you zoom out and look at the trillions and trillions of particles that make up, say, a glass of water, the story totally changes. There are just so many more ways for those particles to be jumbled up and disordered than for them to be perfectly ordered. It's just overwhelmingly more likely. And this quote really hits the nail on the head. The arrow of time that we feel isn't some rule that a single atom has to follow. It's an emergent property.
It only appears when you have a huge crowd of particles. It's the law of large numbers in action.
Okay, so this leads to a really wild thought. If this is all just about statistics and probability, could time, theoretically, ever run backwards?
For that to happen, we need to see entropy spontaneously decrease on a massive scale. We would need to witness the universe winning an impossible lottery. A shattered glass would have to leap off the floor and put itself back together. Smoke would have to unburn and turn back into a perfect match.
And here is the truly mind-bending part. Technically, it's not impossible. The laws of physics don't forbid it. They just say that it is so fantastically, astronomically unlikely that you could wait for trillions and trillions of years and never, ever see it happen. The universe doesn't say no, it just never goes that way.
Which brings us back to this beautiful idea from Feynman. The reason our world has any order at all, the reason a glass can be whole before it shatters, is that our universe has a memory. And that memory is the incredibly special, orderly state it was born in at the Big Bang.
So in the end, we're left with this massive question. Is the arrow of time some deep, fundamental law of reality? Or is it just a feature of our particular cosmos? A historical accident that happened 13.8 billion years ago, which wound the clock and set it ticking in one and only one direction.